Let me talk about machine. Well, any appliance that enables a small force to get the effect of a greater force is called machine. We can call it as a machine. So the force applied is called effort and force overcome is called load. Now let me define mechanical advantage. This is the ratio of load divided by effort. Okay, so mechanical advantage is load divided by effort. Now, this is applicable to all types of machines, whether the machine is simple or complicated. This is applicable to all types of machines. Now, let's have this simple example. And here, what is happening? The load is 150 kilogram force. And the effort is 10 kilogram force. So, we can write that mechanical advantage is load by effort, and I had a load of 150 and effort was of 10, so I get mechanical advantage as 15. So how can I interpret this information? Yes, if the machine were perfect, the effort will be 1 by 15. So we can write like this. This 15 is also equal to 15 by 1. So the effort will be like this, 1 and 1 by 15. So if the machine were perfect, the effort will be 1 by 15 of the load. Now let's have another types of definition, that is velocity ratio, and this can be defined as distance traveled by effort divided by distance traveled by load. Well, if we compare mechanical advantage, the mechanical advantage is the ratio of load and effort. It is load by effort. However, the velocity ratio is distance traveled by effort divided by distance traveled by load. So this is distance effort divided by distance load. Well, this formula is applicable for simple and complex machine. So now let's define efficiency, and efficiency is work out divided by work in multiplied by 100. So what is work out? We can write this work is equal to force multiplied by distance. So the force is here load and distance traveled by load. Similarly, work in is effort and distance traveled by effort. So efficiency is going to be work out, that is load and distance traveled by load divided by effort and distance traveled by effort. So both the cases here. Okay, now let's put it this way, that load by effort, load by effort is the mechanical advantage, and distance traveled by effort divided by distance traveled by load is velocity ratio. So this is 1 by VR. This load by effort is 1 by VR. So we can write like mechanical advantage divided by VR multiplied by 100. Let me repeat this here. Velocity ratio, what we got was distance traveled by effort divided by distance traveled by load. So 1 by VR will be distance traveled by load divided by distance traveled by effort. So we use this information here, 1 by VR. Well, for perfect machine, mechanical advantage should be equal to velocity ratio. So if this is equal to 1, efficiency will be 100%. So now let's talk about types of simple machine. Well, this is a simple lever, and here this is the force applied, say P, and this is the weight overcome W. The distance here it is OA, and here the distance is OB. So the load W is moved by effort P. We can have this relationship that P multiplied by OA is equal to W multiplied by OB. And we can simplify this, that W by P, let's write here W and you take P here. W by P will be equal to OA divided by OB. So W by P is mechanical advantage, and this is equal to arm of effort divided by arm of load. Well, let's have another example of pulley, and here is the weight W and we are pulling it with the force. So this is an example of single fixed pulley, and here distance traveled by effort is equal to distance traveled by load, and as per the definition of velocity ratio it is going to be 1. So efficiency will be 100%, and mechanical advantage is equal to velocity ratio is equal to 1. Well, here W is equal to P, so the mechanical advantage is equal to 1. And the advantage of this pulley system is that the direction of effort can be controlled. Let's talk about this two pulley system. Now there is this pulley A and this pulley is P, and you are pulling it like this. So the distance E, that is distance traveled by effort, is 2 pi r, and distance traveled by load is 2 pi r divided by 2. Why? Because there are two pulleys involved. So length of the cord at A, just let me mark here, length of the cord at A is divided into two parts at B. So here it is divided into two parts at B, the length of the cord at A. The length of the cord at A, is divided into two parts at B. So we have this relationship velocity ratio, which is dE, distance by effort, divided by distance by load, and that is equal to 2. Well, velocity ratio and mechanical advantage will be 2 if the efficiency was 100%. So here the velocity ratio will be equal to mechanical advantage and the vehicle if the efficiency was 100%. Now let's have another example of gun tackle. So here is identical with pulley arrangement as shown. So here the moving parts at load is 2. This is the load. So there are two moving parts, and moving part at effort is just 1. So velocity ratio is 2 by the same logic. So the number of moving parts at moving block, if pulleys are smooth, is that means you'll get the mechanical advantage is equal to 2. Now let me just let's examine this. So this is the effort. Number of parts at moving blocks are 3. Can we see 1, 2 and 3? So here the velocity ratio is 3 and the direction of pull and load is same. So this is called rig to advantage. Now you may be wondering how it is called rig to advantage or rig to disadvantage. So if the direction of pull and direction of the movement is same, so here is the pull and direction of movement is also same, it is called rig to advantage. However, here the direction of pull is downward and the movement of this block will be upward. So this is called disadvantage rigging. This is the standing block, or this is a standing block, and these are the running parts, the parts which move, and this is called hauling part, This one is also hauling part, and this block is called moving block, the block which moves here. So let's talk about purchase. Mechanical device by means of which an applied pull or force is increased is called purchase. Examples are system of levers, which we studied, or system of revolving drums, or wheels geared to one another, or combination of blocks or pulley with rope or chain. So let's talk about tackle. That's the purchase consisting of a rope through two or more blocks. The force applied on hauling part results in an increased force by an amount depending upon the number of sheaves in the block and the manner in which the rope is rove through them. This is the block here, and these are the number of sheaves. So here 1, 2 and 3, there are 3 number of sheaves, and it will depend how the rope has been roved through.